Example 3 is asking if triangle ABC and triangle BCD are isosceles. First of all, then we have to know what isosceles means. So going back to isosceles, we talked about before, isosceles kind of looks like an ice cream cone. So it's got two sides that are the same length. So that's what we need to see here, if these have two sides that are the same length or not. These are actually going by ones here, so it's up to you which method you want to use. It's totally up to you which way you prefer here. Notice with A and C we're looking at the x values. So A to C, those are in different quadrants, so we're going to be adding their absolute values. So basically -5 back to the y-axis is 5 units, and then one more unit gives us 6. And then if we look at BC, looking at our y values this time, we're going from 2 to 8. Those are in the same quadrant, so we'll subtract those. From 2 to 8 would be 6. So this was 6 and this is 6. The shortest distance between 2 points is always a straight line. So AB is actually going to be less, it's going to be more than 6, but it would be less than 6 plus 6. Okay, in other words, if I'm walking along this red line here, that's a further distance than if I would just walk straight on this black line. Okay, so it's more than 6, but it's less than 12 basically. So anyway, we've got two sides that are the same, so that one is isosceles. And if we look at the other triangle, going from C to D, those are in the same quadrant, so we're going to subtract those. That's x's go from 1 to 7, so from 1 to 7 is a difference of 6. And then BC we already know is 6, so that would be isosceles as well. So you can see both of those triangles would be isosceles. On the try it, Joaquin says that quadrilateral ADEF is a square. Is he correct? So we know for it to be a square we have to have all four sides have to be the same. Across the top we actually already know that 2 6s makes 12, so segment AD is going to be 12 units. So the question is, do we have 12 units going up and down here? So A, looking at the y values, A is at 2 and F is at -8. It's kind of cut off there, the negative sign, but it's got to be a negative down there. So from A to F, these are in different quadrants, so we're going to add these together. So we'll add 8 and 2. Again, it's 8 units from F back to the x-axis, and then 2 more units from the x-axis to A. So that's a distance of 12. A distance of 10. That's 10, and these other ones, that was 12 across the top, would be 12 across the bottom as well. So that is actually not a square. So we could say that it's actually not a square. It would be a rectangle, however. So the key concept here kind of just recaps what we've been talking about before, adding or subtracting absolute values to find lengths, and then again sometimes they'll ask us to find the perimeter as well. Okay, we're going to go ahead and look at the workbook, page 25. We got some pictures there we can look at for graphing. So workbook page 25, number 1. What's the perimeter of rectangle ABCD? ABCD, our rectangle on the left here. First I'm going to check what they're going by. And you can see that second mark there is a 2, so that'd be a 1. Over here you can just double check, -1, -2, -3, -4. So they are going by 1. So with this one I would just count how many squares we've got. Okay, and again, you know, if they were going by fives, you could just count by fives if you wanted to. So A to B, that's 3 squares across there. So the bottom would be 3 squares also. A to D, we got 1, 2, 3, 4, 5, 6. So 6 on the other side as well. Okay, again, if we pair these up, 2 3s is 6, 2 6s is 12, and that's a total of 18. Sometimes they give us units and sometimes they don't. This one they didn't. They didn't say meters or feet or anything like that. So what you can do, you can just say 18 units would be our perimeter. Skipping over to number 5, Madison used a coordinate plane to map out an L-shaped herb garden shown at the right. Each unit on the grid represents a half yard. To buy fence for the garden, she needs to know its perimeter. What is the perimeter of the garden? Okay, so this one, each unit is a half. So you can use the coordinates, you can do absolute values if you want to. Another option is just to count by halves. So like going from A to B, we got a half, 1, 1 and a half. B to C, same thing, 1 and a half. C to D, half, 1, 1 and a half, 2. D to E, same thing, is going to be 2. If you look at E to F, we got a half, 1, 1 and a half, 2, 2 and a half, 3, 3 and a half. And A to F, a half, 1, 1 and a half, 2, 2 and a half, 3, 3 and a half. And then finding the perimeter, then we just need to add those together. So you can see here we've got 2 halves makes a whole, another 2 halves makes a whole. So that's 2. Basically, if you want to just say we're going to carry a 2, that's fine. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14. And those are in yards. So 14 yards would be our perimeter. Okay. And 6 and 7 kind of follow up with that. Kind of similar type questions. So we're going to skip over to 13, part B. We have a vertices of a triangle given, and it says give the coordinates for 2 points that are 5 units from point Z. So point Z here doesn't have real great numbers that we're working with, but we can kind of just think about what's going on here. Basically we could be 4 different directions with what we've learned. 4 directions from point Z. We could be left of it, right of it, above it, or below it, 5 units. So you think about if we had that point, if we went 5 units to the left, 5 units to the left, that would be affecting our x value. Our x-axis goes across. So if we're at, our x value is at 4.5 right now, and we take away 5 from that, well, take away 4.5, and then we're going to just go a little bit further. So I guess we'll call it A being our first point here. That's actually just going to be at -5/10, and then -5 2/10. A little bit easier, maybe a good first choice for you guys. Better than that would be if you go to the right 5 units, since we're already in the first quadrant. if we can just stay in the first quadrant. Quadrant 1 has, some positive numbers. Oh, sorry, actually we're in quadrant 4, aren't we? Because our y is negative. Okay. Anyway, if we move 5 units to the right, we're at 4 5/10. We go 5 units further to the right. So we're just going to add on to that, would be 9 5/10. So 9 5/10, negative 5 2/10 would be another point. Technically that's already 2 points, so we're done. If you wanted to, we could either go above that or below that. Since the y is negative here, it may be easier for you guys just to stay in that quadrant, like I mentioned earlier. Stay in that fourth quadrant by going down. So we're at negative 5 2/10. If we go down another 5 units, basically if we just ignore the negatives for a minute, we go down, that's going to take us down to negative 10 2/10, taking us more into the negatives. Okay, kind of like if you owed $5.20 and then you owed another $5, then you're going to owe $10.20. So this gives you an idea of how to work with polygons.